8.5 properties of logarithms. One thing that I've said a lot about logs is that logs are exponents. I also think that logs are inverses of exponents, which is true. I want to focus on logs being exponents today. That means if I have like 2 to the third equals 8, well, 3 here is the exponent, so log base 2 of 8 is 3, because the equal signs means is. The log is the exponent. Well, if I'm reminded of some properties of exponents, I know that b to the a times b to the c, the letters here are kind of weird, but I'm using b for base, becomes b to the a plus c. Multiplication became addition. Well, this goes the direction with logs. If I have log base b of a plus log base b of c, that becomes log base b of a times c. Here, multiplication became addition. Here, addition becomes multiplication, and that makes sense because logs are the inverses of exponents, of exponentials. So multiplication becomes addition, addition becomes multiplication, it works either way. Another example, we know that b to the a over b to the c becomes b to the a minus c. Over here, the log rule, log base b of a minus log base b of c becomes log base b of a over c. The third one is the really, really useful one. It says that log, so I'm going to start with the exponent one. The exponent rule would be x, let's stick with our base, b to the a to the c becomes b to the a times c. That's the exponent rule. I'll let down just a little bit. Yeah. Well, over here in logs, this is a very, very useful property of logs. It would be log base b of a to the c. This now has a subscript, script, and a superscript. Subscript, script, and superscript, which I get is annoying, but you can live with it. If you'd like, I can write it like this. This is the same as c times log base b of a. That's the most useful property of log. We will rely on it like crazy. That c could be inside or outside the parentheses. I could have written it like this if I'd wanted to. But my goodness, it's useful, and you'll see why in a second. Actually, you'll see why in a day. These are our 3 main properties of logs. A couple more properties come out of that. I mean, that really tells us that b to the log base b of a equals a, or that log base b of b to the a equals a. Those are 2 other little properties that kind of come out of those first 3. These are your 5 main properties of logs that we'll work with a lot. Here's what you can do with them. One thing you can do is condense, meaning put things together. Now subtraction becomes division. So by the properties that I had listed on the last page, in fact maybe I'll go double screen here. By the properties I have listed on the left, now that this becomes log base 3 of 2 over 8, which is really log base 3 of a quarter. And we'll just leave that like that for now. Parentheses or no parentheses are fine. So here, this becomes multiplication. Addition becomes multiplication. This is log base 8 of 48 minus log base 8 of 3. And then subtraction becomes division. So this becomes log base 8 of 48 over 3, which is log base 8 of 16. And we can actually simplify it down a little bit further if we wanted to, but for now that's okay. Okay, now these coefficients come up in top as powers. So this 5 comes up here as a power of x, and this 2 comes up as a power of x. You can think of it as being a 2 or a negative 2. It works out the same either way, and I'll show you what I mean. This becomes log base 7 of x to the 5th, minus log base 7 of x squared. So I'm going to keep this negative here and just pull the 2 out. Well, then subtraction becomes division. So it's really log base 7 of x to the 5th over x to the 2nd, which is really log base 7 of x to the 3rd, and we've simplified it. We've got it all down to one compact log expression. The other way you could do this same problem is, I have log base 5 log base 7 of x minus 2 log base 7 of x. Well, when I pull the powers up, so I have log base 7 of x to the 5th, I can take the negative with the 2 and make this plus log base 7 of x to the negative 2. Take the negative with the power. Well, this becomes multiplication. Addition is multiplication. Log base 7 of x to the 5th times x to the negative 2, which is really log base 7 of x to the 3rd, which is the exact same thing we got here. So it doesn't really matter what order you do that in, you can just go for it. That's condensing, taking a bunch of logarithmic expressions and writing them as one logarithmic expression. Expanding is doing the opposite, pulling things apart. I'm going to go to one screen now. I'm going to pull these apart using the same rules. So I know that this right here is multiplication, and that multiplication becomes addition. It's going to be log base 4 of 2 plus log base 4 of x. And then the division becomes subtraction. So it's minus log base 4 of 3. And we'll talk about why this is useful later on. It's worth noting this is just some number. We could calculate it. In fact, in this case, it's a half. This number just equals a half. Log base 4 of 2 is a half. This is also just some number. It's going to be some ugly, ugly, messy decimal, but one that we can calculate. This, however, still represents an unknown. But the point is, if I'm going to expand this, this is how that expands. That's simplified. So here, multiplication becomes addition, so it's log base 3 of 3 plus, I'm sorry, that's base 10, not base 3. This is just log of 3 plus log of x squared, and then minus log of 2, and minus log of y squared. Because everything on the bottom is really subtraction. It's division. Division becomes subtraction. So I had to subtract both the log 2 and the log of y squared. Then my powers come out in front. I have log 3 plus 2 log x minus log of 2 minus 2 times the log of y. Because these powers come out in front as multipliers. This is expanded, where every single log has only one thing in its parentheses. Basically, if you want to think about that in the function, there's only one input, and each log has its own expression, its own term. Finally, we can solve. Now, this problem right now, on the left side, there's more than 2 logs, so I can't just drop the logs. I can't do it because there's more than one log on one side. But I can combine these. This becomes log base 5 of 30 over 2x. And really 30 over 2x is 15 over x. So it's log base 5 of 15 over x equals log base 5 20. Well, now that I'm down to one log on both sides, now I can just drop the logs. So I'll cross multiply, 15 equals 20 times x, divide both sides by 20, 15 over 20 equals x, and 15 over 20 is really 3 over 4. So x is 3/4. That solves that equation. Once you get it down to just one log on both sides, just drop the log and solve from there. Again, I've talked in the past about how you're really exponentiating, putting a 5 to both powers of these, but don't worry about that for now. So here it looks like we have just one log on both sides, but this 2 on the right is kind of ruining things. So instead, let me erase this real quick. Instead, we have to pull that 2 up as a power. So it becomes log of x squared equals log of 16. And now I can drop my logs. X squared equals 16. So x equals plus or minus 4 when I square root both sides. However, negative 4 isn't going to work as an answer. I can't do the log of a negative number. So my solution is just x equals 4.